Introduction to graphing parabolas. The general form for a parabola would be y equals ax squared plus bx plus c. In that form, the equation wouldn't tell us much other than the zeros or the roots of the parabola. In other words, where it crosses the x-axis. For the standard form, standard HK form, we have y equal a x minus h quantity squared plus k. This form gives us a little more information about where the vertex is. That's what we call the HK. It also gives us a clue about how to graph the parabola. That's why I call this the introduction to graphing parabolas. And so I want to go to some of the characteristics here, explain how you read the standard HK form and how we'll work with that. So I've got y equal a times a quantity x minus h squared plus k. If you're given an equation in this form, or more times than not you'll have to convert to this form, you'll be able to extract the vertex. You'll take the opposite of what you see in your parentheses and keep the value that's on the outside, and that will tell you where to start your parabola. The value of a tells us a lot of different things. So you see in my notes here, we're going to go through this. If a is positive or negative, it tells us stuff. If a is a negative value, we know that our parabola will open downward when we're solved for y. So a negative value for a will force your parabola to open downward. If a is positive, it'll force the parabola to open upward. Negative a values, the parabola opens downward. Positive a values, the parabola opens upward. And then I use the word magnitude here. Magnitude means I don't care whether it's positive or negative because I discussed those values up here. I'm more worried about the number itself. So if we're looking at a as a proper fraction like 1/2, 2/3, 1/5, negative 1/3, negative 1/2, we're saying that it's less than 1, we know that our parabola when graphed will have an obtuse opening. An obtuse opening just means it's wider than what we typically expect. If your a value is equal to positive or negative 1, again that's what the absolute value is saying. It says I'm only looking at the number, I'm not looking at the sign, because we already discussed what the sign would do. If a is 1, the parabola will have a standard opening. And that'll really be the focus of a lot of the videos you see in the next couple series, is this standard opening. If a is greater than 1, the parabola will have an acute opening. Now, what I would like to do, when we say greater than 1, we say 2, 3, 4, negative 2, negative 3, negative 4, whatever. I would like to go through a couple examples where I already give you the equation in this HK and we just look at those characteristics. So we're going to call this idea 1. I've got y equal negative 1/3 x minus 2 quantity squared plus 5. Given this information, I should be able to extract a vertex and describe the parabola. So when I look at this, I'll take the opposite of what's in the parenthesis. I have a vertex at 2. And I'll take this value here. I don't change the one that's outside. I keep what's on the outside. I have a vertex of 2, 5. I know it's going to open downward because a was negative. This value here was negative. And because it was a proper fraction, I know that it would be an obtuse opening. I get all that information just from the form. And very soon we'll show you how to graph them. Let me do another idea. Idea 2. We'll say y is equal to negative x plus 3 quantity squared minus 2. From this parabola, I can extract a vertex. The vertex would be negative 3, comma, negative 2. So you take the opposite of what's in the parenthesis and keep what's on the outside. Looking in front of the parenthesis, my a value, it's an implied negative 1. Because it's negative, once again it would open downward. So it opens downward. Because it's a 1, it tells me it would be a standard opening. And let's do a third example here. Idea 3. Y is equal to 3. X minus 1 quantity squared plus 5. When we look at this, we should be able to extract our vertex. Our vertex will be 1, 5, because I took the opposite of what was in the parenthesis, kept what was on the outside. I look at this leading value, this multiplier here. Because it is positive, it would open, the parabola would open upward. And because that value is bigger than 1, it would be an acute. It has a vertical stretch, so we'll call that an acute opening. And that basically just gives us an overview of what we're going to be working with today.